Alright, so today we are going to start Chapter 9, Lesson 911. Our key lesson question today is going to be about how can I calculate the volumes of right rectangular prisms. Before we do that, let's just check in to see how everyone's weekend was. Just go ahead and type in the chat box one thing you did this weekend. Oh, very good. It looks like Mike went to the mountains and Sarah went kayaking. That's great. All right, well, we're going to start a little bit by talking about just some of the different dimensions in math class. So don't be disappointed. I know this is Mike's favorite band, but when we're talking about one dimension or 1D, no, it's not the band, but if an object has length but no width or height, we're going to say it's one dimension. A line is an example of a one-dimensional object. We also have a two-dimensional object, or 2D, which is when an object has length or width. So that would be like a rectangle, a square, some of the shapes that we've already found area of this year. Finally, most objects in the world have length, width, and height. So they all have 3 dimensions. So in this section, we're going to look at some 3D or three-dimensional objects. So just to make sure that everyone's on the same page, I'm going to show you a picture. And in the chat box, you're going to give me a 1 if it's an example of a one-dimensional object, a 2 if it's a two-dimensional object, and a 3 if it's a three-dimensional object. Thumbs up if you understand the direction. That's going to be under your name where that smiley face is. Thumbs up if you understand the directions. Mike's got it. I'm waiting on Sarah to see if she's got it. Underneath her name, there should be a thumbs up. Hopefully Sarah's still there. Sarah, if you can't find it, so you can just write thumbs up in the chat box. Not sure where Sarah went. Hopefully she's still there. Alright, well, we're going to keep going. Sarah, if you jump in, hopefully you can still hear the directions. So here we go. First example is up on the board. Remember, 1 in the box for one-dimensional, 2 for two-dimensional, and 3 for three-dimensional. There's Sarah. She has thumbs up. So 1, 2, or 3 in the chat box for which example you think it is. Mike's going with a 2. Waiting on Sarah for an answer. Okay. Sarah also says 2. Lovely. Bonus question. Anybody know what shape that is? You can put an answer in the chat box. Sarah guesses 2 again. That's good. Anybody know what shape that is? Anybody? No takers? Oh, rhombus. Close. It has 4 sides. Good guess, Mike. Not quite, though. This has 1 set of parallel sides. Oh, Sarah, that's close. That has 2 sets of parallel sides. I was looking for trapezoid. Okay, trapezoid is what I was looking for. All right, next example. Here we go. Is this one-dimensional, two-dimensional, or three-dimensional? Oh, Mike's in again quickly. That's a 1. Sarah also says 1. All right, by raising your hand, again, that's going to be underneath your name. Anybody know what that's called? It has an end point and an arrow. Raise your hand if you think you might know. Oh, Mike and Sarah are both in. Mike, I'm going to turn your mic on. What do you think it is? Go ahead and say your answer.
Is it a ray?
Oh, he's got it. It is a ray. 1 point for Mike. All right, you can go ahead and put your hands down. Just click it again. All right, I've got one more. All right, is that going to be 1-dimensional, 2-dimensional, or 3-dimensional? Oh, everybody says 3. That's great. That's actually going to be a pentagonal prism because the bottom is a pentagon. Raise your hand if you know how many sides a pentagon has. Oh, Mike's in first. How many sides are in a pentagon? Sarah also has it. Now, Sarah, I know your voice chat isn't, or your talking isn't working. Can you write in the chat box how many sides a pentagon has? Go ahead and put it in the chat box. Oh, 5. Beautiful. We've got it. All right, you can put your hands down. So we're going to talk a little bit about being an architect. So Sarah and Kathy, who couldn't be with us today, are studying to be architects. They've asked to design an office building, and they've come up with these 3 possible floor plans. So they don't know how many stories yet they want to make each building, but they want all of the buildings to hold a similar number of offices. Okay? So if each office takes up 1 cubic unit, how many offices will be on this first floor? So for number 1 here, Mike, I want you to decide how many offices will be in this one. And Sarah, you're going to go ahead and do the second one. Just raise your hand when you think you're ready with an answer. Each cubic unit is an office. So how many offices would be on the first floor? So Sarah, you're looking at number 2. Just raise your hand when you think you know how many offices will be on the first floor. Oh, she's got an answer. All right. Mike, go ahead and tell us how many you have.
What is 6?
Oh, what is 6? Jeopardy style. 6 is right. Sarah, go ahead and type in how many you have. She's got 6 as well. Beautiful. All right, so they've decided now that we want to make this building a little bit taller. So I have 3 questions for you. How many offices would fit in this building if it were 2 stories, if it were 3 stories, or if it were 9 floors high? I'm going to give you a second. You can go ahead and put your hands down and then give me a thumbs up when you think you have the correct answer. All right, it looks like everybody's ready to go. So Sarah, can you go ahead and just type in your 3 answers? Looks like she has 18. 6 times 2, wasn't it?
Yeah.
I mean 12. Oh, she means 12. Okay, I think that was her first answer. So we're going to go 12 for her first answer. Number 2 is 18, she says, and number 3 is 54. You got it. So, Mike, you should have had the same answers because all of our first floors are starting with 6, so everybody is good on that. So what we've just done here is volume, which is the number of cubes it takes to fill a 3-dimensional object. The volume of the building was equal to the number of the offices. We're looking at what is the relationship between the number of floors and the number of office buildings or volume for your entire building. So raise your hand when you think you have an answer. How did you get the answers of your 2 floors and your 3 floors and 9 floors? Mike is just on top of it today. Sarah's in there as well. All right, so I'm going to turn on your microphone. Go ahead and tell us how you got your answer.
Well, Mrs. Gorman, I took the number of offices and multiplied it by the number of floors.
Oh, that's just wonderful. You got it. Smiley face there. All right. Um, all right, so we actually, since Mike is just doing so well today, we have a problem about him. You can go ahead and put your hands down. Mike built a box that is 5 inches long by 6 inches wide by 7 inches high. He started filling it with his 1-inch cube, and when you see that symbol, it stands for inches there. I'll go ahead and circle it. This means inches. He realized quickly that he didn't have enough cubes to fill up that box, but he wants to figure out how many cubes it could hold. So, go ahead and see if you can come up with an answer. When you're ready, you can go ahead and put your answer in the box. Now, it looks like Mike does have an answer ready, but I do like how Sarah put in, it should be cubic inches because we're talking 3-dimensional. Okay, if we were in 1 dimension, it would be inches, but because we're talking about volume, it is cubic inches. All right, so here we go. We're almost through here. Just real quick, though, let's do a quick check-in. Smiley face if you're doing great with this information. Confusion face if you're feeling not too sure. Oh, Mike has a smiley face. Oh, and he's laughing out loud. Beautiful. Sarah has a smiley face. Okay, here we go. We've got 2 more slides to do, and then it'll be time to head to lunch. All right, I have 2 problems that I'd like you to find the volume of. Go ahead and figure out your answers, and then just put a hands up when you're ready to go. Oh, no worries about that, Mike. Sometimes we just forget. Oh, Sarah was quick on this answer for this one. Sarah, why don't you go ahead and type in your first answer in the box? Oh, and she remembered her label, 60 cubic. Now be careful on that. We're in centimeters, so this one's going to be centimeters cubed, but I like that you remembered cubed. Mike, go ahead with your second answer. I'll turn on your microphone.
I'm going to go with 36 cubic feet.
Oh, cubic feet. He got the cubic and the correct label. Beautiful. All right. We are about out of time today, so you just have one more thing that I need you to do for me. Let's just pretend that our friend Kathy today is absent from class, so she needs to know something that we talked about. So in the chat box, just leave me one note about something that we talked about in today's class. You could think about the dimensions that we talked about, how we solved, how to find the volume. Just put that in the chat box, and then you can go ahead and log out. They're typing away. Mike's typing away. All right, good. Sarah has that length. Cubic units is what Mike's going to remember to tell Kathy. All right, that's where we're going to stop for today. I will talk to you all soon.